Welcome to today's session, Synergy Applications in an Interconnected World. My name is Liz, and I'm joined by our presenter, Steve Ives. Steve has worked as a technical consultant and trainer for Synergex since 1997, developing e-commerce applications and helping companies maximize their vertical market software applications. Steve has experience with networking, building, and managing internet connections, and with security firewall solutions. So he is certainly someone you're going to want to hear from on this topic. So without further ado, let's do just that.
Good morning. So in this session, we're going to consider all of the different ways that applications interact. Today is a very interconnected world. Back in the day when many of us started writing our applications, those applications were kind of islands of functionality, and as long as they did their job, nobody really cared what they were written in or how they did it or what platform they were on or what language they were written in. And if integration with something else was a requirement, then how we did that integration didn't really matter to anybody as long as it worked. Thankfully, maybe not, but those days have gone. These days we're all absolutely required to expose and consume data. We're expected to do that securely. We're expected to interact with other applications. We're expected to do that using open standard mechanisms and protocols and so on. So in this presentation, I'm going to explore the many ways that Synergy apps can interact with other applications and consider some of the best architectural strategies for doing so with the current tools that we have access to. Integration is critical, data is king. I think that's fairly obvious. But integration means so many different things to different people, depending on what your application does and who your business partners are and who your customers are. It can mean some very different things. But one of the things I've learned recently in helping people with various integration projects is, surprisingly, some of the very oldest techniques, like flat file transfers, are still some of the most popular mechanisms in use. And there are some modern alternatives and better ways of doing some of those things. But when you consider it, really the basics are one application needs to send some information to another application to cause it to do something, or needs to retrieve some information from another application to learn something about that application's data. Sometimes that's internal communications between two internal systems. Sometimes it's between trading partners or customers or other business entities. Maybe there's a response, maybe there's not. In some cases, people just drop a file in an FTP location, and hopefully something happens later. Maybe there's a response directly to that request. Even if there is a response, that response might be in real time, or it might be sometime later through some other mechanism. So there's lots of different requirements, different ways of going about things. But at the end of the day, it's all about exchanging data. I put my mind to it and thought about, well, what are some of the things that I've seen and that Synergy developers typically have used to implement these kind of interactions between systems and between applications. And I'm not going to read through them all, but the things on this slide are the things I'm going to address, some of them in more detail than others during this presentation. Integration, as we've already mentioned, means basically exchanging data, and that's the fundamental thing that all of these integrations do. But that data might be in various different formats. There are different ways that have been, some of them more standardized than others. We've got things like EDI documents where there's a strict definition of the format of data that's defined and exchanged. That data might be in different formats, but there's a rule to say this type of document is represented in this specific way, and it's a standardized thing that everybody adheres to. And then we've got more loosely defined things like XML and JSON and delimited files, all of which could be used as EDI documents, but less formalized scenarios for exchanging the data, not based on accepted industry standards, but using these data formats. You're all probably very familiar with XML. It's been around an awful long time now. It was standardized circa 1998, but still in very popular use. But certainly being replaced at a rapid rate by JSON. The JavaScript object notation is what JSON stands for. it was standardized in 2013 and is now probably the fastest growing way and the most used way of representing data. It's fast replacing XML simply because it's much more concise than XML and therefore smaller and faster and easier to transmit. And delimited files, simple CSV files, still are frequently used in mechanisms where data is being exchanged between systems. So how might we consider interacting with all of these things in Synergy? Well, XML data in Synergy, we're all probably familiar with the fact that we do have in traditional Synergy and in Synergy.net an XML API. So that API is specifically designed to help you construct and parse XML documents. There's an example of some XML on the right-hand side there. And that API it's supported across all traditional Synergy platforms and also in Synergy.net. But as is often the case, if you are in .NET, then you have lots of other options. So if you're in .NET and you prefer to use native .NET framework or .NET APIs, then the whole system.xml namespace is there to help you. And there's lots and lots of any number of third-party libraries that are designed to help you interact with and construct and parse XML data that you'll find in NuGet and various other places. So dealing with XML data is fairly straightforward in any of our supported platforms, including .NET. Processing JSON data is a more recent requirement. A lot of us are becoming or have become exposed to it more through Harmony Core, where that's its native format for exchanging data. We do have some ways in traditional Synergy of dealing with JSON data, both again assembling JSON data and parsing JSON data. We have a couple of mechanisms, one of which is more formalized than the other. Actually, I think the first one, JSON.dbl, which is actually shipped as part of Harmony Core, but it's out there to grab and use if you want to, I believe, if I'm not mistaken, was actually written on the airplane on the way back from the New Orleans conference in 2018, where somebody said to Jeff, "Hey, have you got a JSON parser?" And yeah, he had by the time he got home. And it's still out there. It works on, the advantage of that one is it works on Synergy 10, which was the latest and greatest at the time, still works on 11 as well. It is out there to be used. It's called JSON.dbl. You'll find it in the Harmony Core source repository. We've also added a new one into the product in version 11. It's called system.text.json.json document. It is basically a subset of the .NET JSON document environment. So you can look to .NET for basic information on how to use it. It is only supported in Synergy 11, but it does a little bit more than the original JSON.dbl parser did, and it does it somewhat faster as well. Unfortunately, I'm embarrassed to say that both of these are what I call documented by example, which basically means there is no documentation. Go look at some example code and you can figure out how to use it from there. I do apologize for that, and we will be rectifying that soon. So we will be at least documenting the JSON document parser that is part of the Synergy language in the near future. In Synergy.net, of course, lots of different alternatives. JSON.net from Newtonsoft is by far the biggest example that almost everybody in the world uses to deal with JSON data. So if you are in .NET, remember you can use these things through the .NET Assembly API on Windows in traditional Synergy as well, if you wish to. So JSON.net or the .NET framework has its system.text.json parsers as well if you want to use some slightly lower level tools. Processing CSV data in Synergy is less common. We don't have anything native here. I've seen some people writing their own subroutines. Clearly, it's a piece of data with a comma between it or some separator character, so it's not that hard to do. If you are in the .NET world, or again through the Assembly API on Windows, then the biggest way of dealing with CSV type data in the .NET world is a package. It's open source called CSV Helper. You can see the NuGet references there and the reference to the developer's site. And that's a really good little library that helps you deal with constructing and parsing CSV data. It's as you can see, it's had over 40 million downloads, so it's very, very widely used and recommended. We used it recently on a project and it worked very well. So let's look at the different techniques by which people do integration. Well, some of these we'll go through pretty quickly. Screen scraping. So, a lot of people have done this in the past. It's the process of software emulation of a human interacting with an application, but rather than the human interacting with the application, some piece of software is making a connection to it, logging into the system, running the program, and sending the key sequences and retrieving the things that were displayed on the screen and sort of driving that software. And the purpose for doing that was very often, it was one way of saying putting a new, maybe browser-based UI on a piece of character-based software in the 90s, perhaps. And people still do it today. It's also, interestingly enough, the place it happens more often now is with web-based stuff, because web-based stuff is very easy to screen scrape and drive from automated scenarios. Because it's simple. It's a stateless HTTP request response mechanism. You send a request, you get a response, you figure out what to do next, you send another request. So it's actually very easy to drive web applications from software. Ideally there'd be a web service to let you drive, but sometimes there isn't. Sometimes you just have to emulate somebody going to the website and logging in to make something happen. Screen scraping techniques on character cell systems, usually a network connection to a remote system by Telnet or SSH or some protocol like that. And it's basically a bidirectional conversation. You send keys, or you emulate sending keys, and you receive whatever data comes back. You're basically emulating a human at a terminal to drive the functionality of the underlying software from some other environment. You can possibly do that with the Synergy Sockets API, but it gets pretty complex pretty quickly, because you have to start writing your own Telnet protocol, essentially, or writing code that complies with the Telnet protocol. And it's not as simple as just send data and receive data. There are Telnet special codes that can come back that you have to respond to, and so on. The best way to do this kind of stuff is almost always with some kind of third-party client library or component. Again, if you're in the .NET world, then, and again, remember, you can drive this stuff through the .NET Assembly API on Windows, at least from traditional. Minimalistic Telnet is a fairly popular library by the look of it. And if you're in the SSH world, which hopefully you are rather than Telnet, then SSH.NET is a very popular standard library that is used by a lot of people, including us. That's what we build our Harmony Core traditional bridge services using. Screen scraping web applications is surprisingly simple. Due to the nature of HTTP, again, it's just a request and a response. So you can do it from traditional Synergy or Synergy.NET with simple HTTP API calls. From .NET, you have various other choices, standard framework stuff like web request being the older stuff, or HTTP client being the newer stuff. Bear in mind that HTML is very much like XML, and you can use the Synergy XML parser or other XML parsing tools to parse and construct HTML data as well as XML. In fact, we had a customer recently that let me know they'd had some great success with this recently, where they had a customer who had a website and had a web service that exposed information. I don't know the exact details, but there was a per transaction charge to use the web service, but not the website. So they chose to ignore the web service and screen scrape the website for free, which I thought was a nice little twist. File transfers. This one is, again, surprisingly common these days still. This was probably one of the earliest ways of interacting between applications. Send me a file with something in and I'll do something, and I'll send you a file back that confirms it. That kind of operation. Typically through FTP in the old days, hopefully not anymore, hopefully through something, FTPS or SFTP or HTTPS even, it's very easy to replace FTP with HTTP stuff and add security and performance and just simplify the whole thing. This mechanism might be a push or a pull or both. It might be send a file and it's a black box, you don't know what happens. It might be you pull a file from a remote location to do something, or poll for, is there a file there to pull? Or you might drop a file, wait for a response, and that response might be another file being created that you then grab and pull. So lots of different ways of implementing stuff with this mechanism. Frequently, it was a sort of batch operation, so you just drop a file and it's picked up at some point, maybe just once a day, once an hour, something like that, and processed almost like in a queue mechanism. So there may have been acknowledgements, but they may not have been immediate typically. Very often it was just drop a file in a location and assume that it was being processed later. Receiving transfer files in Synergy. In traditional Synergy, the way we always used to do it was either write a process that literally uses spawn or open pipe to execute dir commands to look for files coming in. Also, it's possible to use the DLL API on Windows or Linux or Unix at least to automate operating system routines. Like on Windows, there's a routine called find first file A, which is essentially like doing a dir. It's just an in-code way of looking at the files in a directory and detecting new files. The modern way of doing this in the .NET world is to use something called a file system watcher, which basically takes the repetitive nature out of it. You know, if you're polling with a directory command or a find first file A, you have to do it every 2 seconds, 2 minutes, 2 hours, whatever the period is. With a file system watcher, it's event driven. So you register for an event, which is a new file being created in a directory, and Windows raises that event and tells you, hey, there's a new file to process. And you can go off and get the file information and process it. So it's a very, very efficient way of writing these kind of processes to receive files that are dropped in a directory through whatever mechanism. Also, modern alternatives, bear in mind that protocols like FTP and so on aren't really flavor of the month anymore. It would be much better to implement, if you have to implement these kind of file exchange scenarios, try and do it with HTTPS protocols or web-based protocols rather than older FTP or SFTP connections. It's a lot easier to do, and it's faster and more secure as well. Also, sorry, just going briefly back to the last file. Also bear in mind that Harmony Core could be used as part of this scenario. You could set up Harmony Core endpoints to post a file to or to retrieve a file from. Sending transfer files, basically, the way we would typically do that in the past is automating an operating system file transfer command. So again, spawning or shelling or open piping an FTP command or an RCP or an SCP command or whatever the file transfer command is. And very often we'd set up a detached process to watch for files coming in. We'd process those files and then use this mechanism to squirt out a response to whatever the sender's location might be. Again, you can also modernize this again with a file system watcher. If you want to automate the process of sending a file out to someone else, then again, you could use a file system watcher so that when your application drops a file in a certain location, you can then get an event and automate the process of sending that file out to that remote location. So file system watcher can be used to both receive and send files if you want to just have the sort of drop folder concept. Also, there's lots and lots of third-party synchronization products. I've listed just a few that I know exist on Windows. Actually, I think Free File Sync works on various platforms. WinSCP, GoodSync, Free File Sync. There's any number of commercial and or free products that you can set up to watch a folder and take actions when it happens, including transferring files to other locations and sending things via email and raising alerts and all kinds of things. Synchronizing files from Windows to OpenVMS specifically. The reason I mention this is in my product update section, I mentioned that using Visual Studio as a development tool for all scenarios and all platforms is doable these days. One of the issues in that regard is how do you get stuff onto VMS? Because a lot of us use Git version control or perhaps Subversion or one of those others that they have clients for Windows and Mac and Linux and all the Unix platforms, but a lot of them don't have clients for VMS. So how do you get that code onto VMS to build? One of my colleagues, Jeff Green, has addressed this in a little free tool called VMS Build Sync. And what VMS Build Sync does, actually, the thing I was just talking about, File System Watcher, it's written in .NET. It uses a File System Watcher. So you can point VMS Build Sync at a root directory of a whole hierarchy of directories, your development environment, essentially. And whenever anything changes, it uses SFTP and zip compression, if it's sending large amounts of data, to send that information over to the VMS system and place it in the appropriate directory on VMS, or unzip that zip file. If it's doing an initial sync, it zips up the whole thing, sends the zip file, and then unzips it onto that remote VMS system and then keeps it in sync. So it can be used. It's a great way of keeping development environments in sync. And then you can use other mechanisms to fire off a build, for example. But also it could be used in data synchronization scenarios as well. If you want to get information that you've received through file transfers onto a VMS system, then you could use this VMS build sync to synchronize that data from a Windows server onto the VMS system. Okay, another way that people implement integration between different systems or different applications, this one's far less common, but it has been done, is custom network protocols. I would recommend that you only go here and only consider this if you have very specific requirements that you can't achieve in any other way. It typically represents a very significant investment in writing both custom client and server-side code, and essentially inventing your own network protocol to run over TCP/IP. An example of this would be our XF Server Plus and XF Netlink products. That was an example where we had a very specific requirement where we wanted something on a client system, be it a .NET or a COM or a Java client or a Synergy client on a remote system, to be able to send a message to a Synergy system and have that message received and result in a subroutine being executed and the parameters being passed in both directions. That's a very specific requirement where a custom network protocol, at the time where this was written, because there are now standardized ways of doing this, but at the time this was written in the mid-90s, that was a totally acceptable and normal way of achieving this kind of thing. So it's really only in those specific scenarios. Technologies, obviously, the Synergy Socket API can be used in traditional Synergy or .NET. And if you are in .NET, then system.net.sockets, that whole namespace there, can help you implementing those kind of specific protocols. The next way people have gone about integrating applications, this one again, not that commonly used, but I've seen it on a few occasions, is database-to-database integration, integration via a database, let's say. So the concept of multiple applications integrating via a shared database in the center, or maybe the database belongs to one of the applications and the other one either reads data from it or puts data into it. Typically, this is only going to be done, it requires a pretty high level of trust between the two applications. Often it might well be a read-only scenario, but in some cases it's not. In some cases, a third-party application is allowed to write data into the database of the other application. But again, typically only in a very high-trust environment where there's absolute control of both sides would be the only time that would probably happen. It's fairly common to give read-only access to a set of tables or views, but maybe not so often to directly manipulate the data. Another approach I have seen is that a database has a special, essentially a queue table, so that there's one application that owns the database, but the other application that needs to cause things to happen can write messages into a table. So just writing a new row into a table with some kind of request or some kind of instruction for something to do that's then picked up and processed by the application owning the database. So that's, using a table as a queue essentially is another way that you could go about integrating. There are various technologies to allow you to consume non-Synergy data if you do need to interact with someone's database. SQL Connection API works with both traditional Synergy and Synergy.net. And can be used very successfully for this kind of thing. And if you are in .NET, then you have, again, as typical, lots of other choices. The system.data namespace is the native database access stuff in .NET, or the entity framework, which gives you a sort of code-first way of accessing data as well. Technologies for exposing Synergy data in this world, well, XFODBC, that's kind of what that was used for back in the day, exposing our Synergy data as if it looks like a relational database to applications that are able to connect through ODBC, hopefully and typically in a read-only scenario, but some people didn't follow that that guideline. SQL replication has been a very popular way of exposing Synergy data to third-party applications for a number of years now and continues to be so. But I would also recommend, in this scenario, consider Harmony Core again. I know this Harmony Core thing is popping up all over the place, but that's kind of the point. It's our way of integrating, period. So, exposing stuff through Harmony Core to third parties. And the advantage there is, whereas ODBC really should be something that's completely read-only, Harmony Core can be completely safely read-write enabled and capable if you choose to do it that way. So it gives you lots of additional options. What does SQL replication look like? Just a little taster. We've done lots of, there have been various webinars on this over time, and there's lots of information on the SQL replication website where the source code is on GitHub, which you'll find linked from our website as well. But very briefly, what SQL replication does is it says, okay, we've got an existing Synergy application with its Synergy data, and through IO hooks. And now, if you watch my product update earlier in this conference, you'll know that we have now also global IO hooks. The difference is, with IO hooks, you have to do a little bit of work in your code to plug them in. With global IO hooks, you don't. You just drop a new piece of code in and magic happens. So literally, with no changes to your code, you can implement a change log, which is essentially just an ISAM file which queues up. It's a queue, so that every time anything changes in one of your ISAM files that you want to replicate, that change is recorded in the change log. And then there's a process called the replication process that simply periodically reads that queue and plays those changes to the database through the SQL connection API. There's virtually no code to write these days. You do have to have a repository that describes your ISAM data and files and keys. And once you have that repository, basically 100% of this scenario, well, let's say 99.9% of this scenario is implemented through code generation. So it typically is something that can be done fairly quickly once you have a correct repository in place. Custom SDKs is another way that people do integration between applications. Again, this is something that used to be a lot more popular back in the day, not so much these days, primarily because of internet technologies and the fact that it's possible to do stuff in real time online now, where it wasn't necessarily back in the day. So custom SDKs, the concept is giving a piece of binary software, a library, to someone that they can call into in order to make something happen. And that something might be network communications with some external thing through whatever means, or it might be creating an extract file or doing a file transfer, whatever it is. The point is that a third party would give you a library that you would link against and call into, in order to make something happen and make the integration happen. It doesn't happen too often these days. If you do have this requirement, then consuming custom SDKs is relatively straightforward in many cases. You might be able to use the DLL API on Windows or Unix or Linux to consume Win32 DLLs or shared objects. You could use the .NET Assembly API to consume a .NET API that's been given to you in traditional Synergy. Obviously, in .NET, you've got full access to Win32 and .NET to integrate with anything produced in another language. And even on OpenVMS back in the day, VMS had something called the Common Calling Standard, which basically meant that almost every language that ever existed on OpenVMS had a common object and executable format. So if you created a subroutine in a library in DBL, then somebody in BASIC can call it, or somebody in C or C++ or Fortran can call your DBL code directly, and vice versa. So that's fairly easy to do on VMS. In terms of publishing custom SDKs, the problem kind of is and always has been the fact that Synergy requires a runtime installation and has runtime licensing requirements. So that kind of precludes some scenarios. It might be possible for you to publish a library written in some standard language that doesn't have those requirements, C or C++ or a .NET language or a Java Bean, to expose some kind of functionality that you then code somehow back into your Synergy environment. Another way that this has been done in the past is with XF Server Plus and XF Netlink. because in that world, the licensing, even though there is licensing and installation requirements, is all server-side. And the client, the XF Netlink side of things, is non-licensed software that anybody can install and use. So giving somebody an XF Netlink.net assembly and the XFNLnet.dll, would allow them to call from their environment into your Synergy environment through XF Server Plus. In these kind of cases these days, really custom SDKs at the application level have kind of gone away now, and I'd strongly encourage you to look at web APIs instead and real-time internet stuff. And again, we're back to Harmony Core. Whether you're calling stuff through HTTP API or whether you're using Harmony Core to expose a web service that third parties are going to call, that's really the modern way of doing this kind of stuff. And now, exactly what we just talked about, onto web services. Web services are the latest and greatest way of doing integration, period. I think the latest figures I saw were something in the order of over 80% of integration between applications now happens through web services. So it's the way of the world. It's the de facto standard. Basically, what a web service is just an inter-application interaction via the HTTP protocol. That's a fancy word for, you send a request, you get a response. That request causes something to happen on the server or retrieves some piece of information, and you get a confirmation or you get that information in the response. It's a very simple thing to do. And it's a very simple thing to implement, certainly in Synergy because of Harmony Core. Widely adopted because, of course, it uses standard technologies, HTTP, HTML, XML, JSON. It's the web, essentially. And the web is so prolific these days that it's just everywhere. It's accessible, it's firewall friendly, and it's just trivial to implement these kind of solutions. We keep hearing this term RESTful web services as well, though. What does that really mean? Really, it's just a fancy way of describing a recipe for how to do something successfully. RESTful web services is not a product or a specific framework. It's a pattern for doing things successfully. That's all it is. It's a recommendation. It's a guidebook that says, this is how you should consider building your web services and making your web services work. And if you follow these guidelines, then there's a certain set of promises that say your web service will be easy to interact with, almost self-documenting because everybody knows how they work. You do a get if you want to retrieve information, you do a put if you want to update information, and so on. Also the fact that RESTful web services are required by definition to be stateless on the back end basically means they typically are very high performance, very scalable, easy to deploy, easy to manage, and so on. So RESTful web services is just the de facto standard for how to go about architecting successful web services. Calling web services is mostly trivial these days, regardless of what language you use. Possibly every programming language now has the ability to issue an HTTP request and receive a response to that request. And like in traditional Synergy, very often it's a single method call. You simply call out, you call a URL, maybe you provide some data, you get a response, maybe it has some data, at least it has a status code that tells you what happened. And it's a very simple thing to do. The most complex part is often if there's any kind of authentication required, that's often the hardest part, just getting authenticated in the first place, depending on how it's done. A lot of public APIs just literally have a secret API key that when you sign up for an account or you're granted access, you're just given a 500-byte random secret string that is your very, very, very long, very hard to guess password, and you pass that backwards and forwards with each request. Sometimes it's more complex than that. Sometimes you have to do a real OAuth 2 authentication flow and exchange credentials for a JSON web token and pass that back and forth like we do in Harmony Core typically. But even so, that's typically not that hard to achieve. So in traditional Synergy or Synergy.net, you call a web service using the HTTP API. It's a very easy thing to do. It's a single X call or function call. to issue a GET request or a POST request or a PUT or a delete or whatever you need to do. And again, as typical in .NET, you've got other options. If you prefer to use the .NET native way of doing things, web request is the older one, HTTP client is the newer one. And again, there's any number of client libraries you can find on NuGet to help you be a web service client or do HTTP stuff. But it's really so simple that it's really unnecessary to go to those extents, I think. Publishing web services does require web development skills, but it's still pretty easy. There are many solutions, many different ways of doing things. But ultimately, if you're a Synergy developer and you're publishing a web service, basically you need a way of getting back into your Synergy business logic and or your Synergy data. So historical options for doing such, we've had the ability to get back into Synergy from other environments like .NET for a long, long time now. If you're using .NET Framework, then ASP.NET has had its original web services, WCF REST, Web API. It's now called MVC, but it's part of MVC. It's been through lots of name changes over the times. And, Synergy.NET has been there. It's usable in any of those environments, or XFNetlink.NET and XF Server Plus can get you back into Synergy from any of those .NET worlds. Equally, so can ODBC. That's a solution that people have used in the past. Just expose the data through ODBC and go at it from .NET code using system.data or EF or whatever .NET mechanisms they prefer. Very similar with .NET Core. We now call things ASP.NET Core, but it still has its basic web services. As of essentially all of the stuff in .NET Core is basically Web API. I think I'm correct in saying that the original web services and WCF do not exist in ASP.NET Core, but certainly Web API and MVC and all of those modern ways of doing web services do exist and are very usable. And of course, that's what we build Harmony Core on top of. We do also have Synergy.NET you can use in that environment. We've supported .NET Core for quite some time now, for at least a couple of years now. XFNetlink.NET will be available in Synergy 12, as I mentioned in my product update session. We do have a preview of that already available that several customers are using. So if you do have an XF Server Plus environment and you would like to start using XFNetlink.NET in a .NET Core environment, then we do have that available. You'll have to sign a pre-release thing. It's not part of the product as such, but it will be soon. And XFNetlink Java, if you're in the Java world, XFODBC is always an option from any of these places. And again, publishing web services, the biggest recommendation I've got today is look at Harmony Core. Again, it's going to do all of the heavy lifting for you. And, I'm not going to go into huge detail. There's other sessions in this conference. I've probably mentioned it several times already at this point. But lots of information on YouTube about building web services with Harmony Core. Another thing to touch on very briefly is message queues. This is something that's popping up more and more. This is not a new technology. These technologies have been around quite a while, but we're starting to see a lot of our enterprise type customers using message queues as ways of integrating disparate applications. In fact, I'm working on a project right now with one of our customers to do just that. The difference with a message queue is that it's typically an asynchronous communication model between two or more processes or threads. So it's kind of similar to the concept of calling a web service, but there's an intermediate in the middle, which is a queue. So if the receiving party is not perhaps available at this point in time, then those messages are written to the queue and will queue up until such time as that intermediate or that receiving party is available and chooses to receive those items. So it can give you a level of a sort of level of disconnect between the client and the server, and as long as the queue is running, then it doesn't matter if the client's not feeding messages in or the server isn't pulling messages out. They can just do so in their own time. So there's lots of advantages. I'm not going to go into huge amounts of details because these products are very, very flexible in most cases. These are commercial products that are are offering these message queue functions. Some of them you can see listed at the bottom of the slide there. MuleSoft Anypoint, IBM MQ is the one I'm working with right now. Azure has a scheduler capability. Lots of different products that do this kind of queuing mechanism. And typically there's multiple ways that you can interact with them. So the one I'm working with right now, for example, is the IBM message queue product. Used to be WebSphere message queue, I think, back in the day. And it probably has at least 10 different ways you can interact with it, depending on what language you're coming from and what preference you have. There are Java APIs to it. There are .NET SDK APIs to it. There's a RESTful endpoint. There's any number of different ways you can transfer flat files in. Lots of different ways of adding something to the queue, and also different ways of retrieving things from the queue. But an interesting concept that can be very useful in many cases. Another interesting thing that we're finding is coming up more and more is the concept of webhooks. And these really kind of started off really in the software development world with things like cloud-based development resources like Azure DevOps and some of the GitHub tools. These webhooks would be used to say, tell me when code is checked in, or tell me when a build is completed, that kind of thing. Now we're seeing them used in business and in commercial software much more. So the webhook is basically a user-defined HTTP callback that is triggered when some event takes place. So an example might be, tell me when you receive a new order. Maybe you've got a website out there somewhere that people are posting orders to, and you've got some piece of software that wants to be notified when the web application receives a new order. So that might be something that you implement a webhook for. Typically, these are HTTP post operations. So a webhook, when that event fires, makes an HTTP request to some URL and passes some piece of data as a JSON payload, typically. And then consumers register for that notification. So they typically would go to a website or through a web service, say, when this event happens, please call this URL. And so you go and register to receive these events, these webhook notifications. That might be a single event. You might say, tell me when this order is complete, or it might be ongoing. Tell me every time you get a new order. Tell me every time a product ships. Tell me every time an order is delayed. Those kind of events that happen in the life cycle. Typically, there's going to be some kind of mechanism to verify that the sender is who they say they are. So you typically provide some kind of secret key that they will give back to you so that you can verify it is indeed them that's calling you, not somebody trying to spoof it. Or some solutions digitally sign the messages with certain private public key combinations, different ways of doing security. But the basic concept is you register for events and then you receive those events because somebody calls your URL. So it's a very efficient subpub or subscribe publish model. And, again, Harmony Core can come into play here because a webhook could trigger a Harmony Core endpoint. So if you need to receive these webhook notifications, Harmony Core is just something you could consider as implementing it, or as a way of implementing it. Here's an example of what webhooks looks like. So without webhooks, something might look like this. We've got a consumer and a server. And the interaction might go something like this, where the consumer says, is my data ready yet? Is this order complete or whatever it is? And the server says, no. So it waits a while and it says, is my data ready yet? No. Is my data ready? No. Is my data ready? Oh yeah, here it is. There you go. And that's maybe what you would have to go through to do that kind of scenario. Versus with webhooks, the approach would be a little bit different. You'd still have the consumer and the server, but the consumer would go to the server and register to receive the hook. So you would say something like, tell me when my data is ready. And by the way, here's a URL to call when it is. And the server would respond and say, okay, yeah, I got that. And then at some point later, the server's going to call the consumer and say, hey, here's your data. And the consumer says, oh, thanks. So that's the concept of a webhook. You register to be notified when something happens. Very briefly about Harmony Core. So Harmony Core is our RESTful web services framework specifically designed for Synergy developers. And it's been designed to be super easy to get up and running with RESTful web services. Once you have a repository, typically, or once you have a method catalog, potentially, or both, more likely, at least a repository, maybe a method catalog as well. Essentially, what Harmony Core can do for you in the short term is give you comprehensive, queryable, data-centric endpoints. So basically what that means is a RESTful web service that exposes all of the data structures in your repository, or at least the ones you choose to expose. You don't have to expose everything. And the word queryable is really important here. Without queryable, which is based on something called OData. Again, I'm not going to get into a huge amount of detail here because there are any number of existing videos on this subject. But queryable is really important. What it means is that you can expose a collection of orders, for example, and then people can query it, order it, sort it, filter it in whatever way they want based off that one endpoint. And that can be a really good ODBC replacement that is significantly simpler, is better, faster, more scalable, and can happily support write operations as well if that's what you want to do. You don't have to. But with ODBC, we did our best to warn people not to do that. With Harmony Core services, you can go ahead and update things to your heart's content if you wish. We also do code-centric endpoints based on method catalog definitions. So this can give us a really good way, and we've done this on several occasions recently now, of basically updating and or replacing XF Server Plus implementations with a far more modern solution that is based on web services, based on open standards, and based on not having proprietary protocols and the requirement to install a proprietary client, and all of those kind of things just go away. So Harmony Core is a great way of running Synergy business logic and potentially replacing XF Server Plus. Also, SignalR is just one of the tools in our arsenal for solving a couple of problems. If RESTful web services are stateless, very often your XF Server Plus backend environments may not be stateless. So there's a big disconnect there with how do you do a RESTful service for a stateful backend. SignalR can solve that problem because it allows you to have stateless backends behind a RESTful service. It also has some really cool features of its own, like enabling bidirectional communications. So not only can a client call a server in a SignalR relationship, but a server can also call a client. So you can do real-time notifications of things to applications and things like that, which is pretty cool. And also custom endpoints. All of that we just talked about is all code-generated stuff. You can also, of course, extend a Harmony Core service with totally custom, either data-centric or code-centric endpoints to do whatever you want beyond standard code-generated stuff. Harmony Core services are secure, they perform really well, and they are very, very scalable. The technologies we build them on is all of the Microsoft .NET Core, or .NET 6 as it's about to be called, stack. And one of Microsoft's biggest focuses for that whole development effort was performance. .NET Core in the web world outperforms .NET Framework by a factor of many times. And we are able to leverage all of that and be very performant and scalable. And of course, it's all based on open source, and it's all based on standards as well. Everything in the entire environment is based on standard technologies. Open Data Protocol, as I mentioned, OData is described on their website as the best way to REST. OData is just again, an open source, standardized now. It used to be a Microsoft custom thing, but it's now open source and standard, used widely in the industry. And it's a way of basically turning, let's call them dumb RESTful web service endpoints into highly flexible endpoints. The way to think of it, the way I think of it, is it's like SQL for web services. It allows you to take an endpoint that exposes a collection of things and select columns, filter rows, order by at multiple levels, expand to drill into joins and multiple levels of data and so on. And it really turns a RESTful web service into something that's extremely powerful. Essentially, Harmony Core turns OData URLs into entity framework queries. The entity framework, or EF provider, is a central part of Harmony Core, but is also usable outside of Harmony Core. Where Harmony Core turns URLs into EF queries, the EF provider turns those EF queries into Synergy select operations. And that's the really clever part. We code generate, based off your repository data definition, something called a DB context, which represents all of the data structures in your entire environment. And you can then code against that DB context to execute queries into the code, or updates or deletes, or create new records and so on. As I mentioned in my earlier product update session, it is a transactional environment, so you can have multi-component operations that are committed or rolled back. Not full ACID, it's not resilient to physical hardware failure and system crashes, but beyond that, it has transactional support. And as well as being the foundation of Harmony Core's data services, this can also be used from Harmony Core code services. So you can write custom code endpoints that interact with data through the EF provider, but you can also use it from any other .NET code. We've got a couple of customers doing exactly that, and not using the whole of Harmony Core, but using the entity framework provider to get a really cool .NET way of interacting with underlying Synergy data with transactional support. I want to very briefly mention Traditional Bridge. Traditional Bridge is the part of Harmony Core that allows us to interact with traditional Synergy code. So that can either be code on a local system, where we can, if we're on a local Windows system, we can spawn a DBR and use it to make X calls and function calls to run your existing code. This can be the heart of how we translate XF Server Plus environments, or it might be a remote system where we log in via SSH and then start a process and run Synergy, traditional Synergy subroutines and functions. The protocol that traditional Synergy uses, and this is the big thing that makes it different from XF Server Plus, is it's based on a standard protocol called JSON RPC 2.0. You don't need to know about that. You'll never see it. It's under the hood. But where XF Server Plus uses a proprietary protocol, Traditional Bridge is entirely based on industry standards. This is what a Harmony Core supported environment looks like, or environments can look like. And the point is that you can configure things in lots of different ways. You don't need all of these lines. Your Harmony Core service might have data endpoints, some of which talk to local data, some of which talk through the EF provider. It might have custom business logic in .NET that uses the EF provider or talks to local data. You might have Traditional Bridge running local subroutines, or any of that might be talking to data on a remote system through XF Server, and Traditional Bridge might be making an SSH connection to that remote system to talk to traditional Synergy business logic, which in turn talks to data. You can configure these things in any combination to achieve whatever it is you need to achieve, and that's what makes Harmony Core so powerful. The point, of course, is that once you've got that one Harmony Core service, you can then hit that service from essentially anywhere, from any type of client on any operating system. It's all just through HTTP messaging, which can be done from anywhere. And again, according to my product update session earlier in the conference, we do plan to support Synergy.net on Linux systems in the near future. It will not be part of the 12 release at the end of this year, but it will be part of Synergy 12.1 early in 2022. So you'll be able to host your Harmony Core services directly on Linux systems. Just wrapping up, some takeaways. Most applications these days require some kind of integration with others. There are lots and lots of different mechanisms, but Synergy is basically able to do all of them. There is always a way, no matter what your requirement is for how to interact with another system, there's always a way of doing it. Almost always, it's through web services these days. RESTful web services in particular are the way to go, and Harmony Core, if you have any kind of integration requirements with other applications, where other applications need to come in to you, then Harmony Core is the way of doing it these days. Again, much more information in the subsequent sessions in the conference, or other sessions in the conference. Some of them have actually already happened. And lots of information on our website, and in particular, when it comes to Harmony Core, there's a ton of content on our YouTube channel.
Again, this might be a little more of a brief Q&A session, as we do want to allow you guys time to head over to our next session. But you will notice, so if you go to the Q&A tab, we have the new, answered, and archived sections for our questions. So during the course of this presentation, Steve was diligently responding to questions that were coming in. So Steve, I was wondering if you wanted to pick one of those to expand on in these last few minutes that we have.
Sure. I think after all three of these were asked, they were answered during the session. Let's just pick out the first one from Doug Ritchie. He was asking, how does the System.io file system watcher work? What happens when files are in transit or being created? Does it wait until the entire file arrives and is closed? And that's exactly the case, Doug. You know, the file created event would happen once the file has been finally closed and fully written. Also bear in mind that you can have multiple file system watchers on multiple directories, and any one operation could potentially cause multiple events. For example, if you're watching two directories and you move a file, copy and paste essentially between them, then it could generate a deleted event and a created event. So, you know, that it will give you whatever notifications you register for, basically.